Welcome back with a new math tutorial. In this video we are talking about estimating roots. We just need to find the closest answer to the square root of non-squared number. So what is the meaning of the squared number? The squared number, the number that has a square root. For example, we can find the square root of 0 which is equal to 0. Because 0 times 0 equals 0. The square root of 1 equals 1. The square root of 4 equals 2. The square root of 9 equals 3. The square root of 16 equals 4. The square root of 25 equals 5. But for the non-squared number, the number that hasn't square root. For example, we can say that square root of 83. 83 is non-squared number because there is no number. If you multiply it by itself, the answer will be 83. So we need to find the closest answer. So just write 83. I need two squared number, one before 83 and one after 83. So you will find that 83 lies between 81 and 100. 83 is close to be 81. So you find that the square root of 81 equals 9. So the square root of 83 is approximately equals 9. In question number 2, we have the square root of 28. Just we write 28. I need two squared number, one before 28 and the other one after that. You will find that 28 lies between 25 and 36. 28 is close to be 25. And the square root of 25 equals 5. So the square root of 28 is approximately equals 5. Now we need to find the square root of 135. So we just write 135. We need two squared number. One of them before 135 and the other after 135. You will find that 135 lies between 100 and 144. You will find that 135 is close to be 144. The square root of 144 equals to 12. So the square root of 135 is approximately equals to 12. The square root of 38.7. Just we write 38.7. And we need to find two square number, one before 38 and one after 38. You will find that 38.7 lies between 36 and 49. Now you'll find that 38.7 is close to be 36. The square root of 36 equal to 6. So the square root of 38.7 is approximately equals to 6. The square root of 35. 35 lies between 25 and 36. 35 is close to be 36. The square root of 36 equal to 6. So the square root of 35 is approximately equals 6. The square root of 170. We know that 170 is more than and less than. More than 169 and less than 196. Now 170 is close to be 169. The square root of 169 equal to 13. So the square root of 170 is approximately equals to 13. If we need to find the cubic root, we will follow the same. But the only difference between the square root and the cubic root, for the cubic root we just need to memorize the cubic number. For example, we can say the cubic root of 0 equals 0. The cubic root of 1 equals 1. The cubic root of 8 equals 2. The cubic root of 27 equals 3. The cubic root of 64 equals 4. Now we need to find the cubic root of 320. So we just write 320. 320 lies between 216 and 343. It's more than 216 and less than 343. You will find that 320 is close to be 343. The cubic root of 343 equals 7. So the answer is approximately equals to 7. The cubic root of 95. Just we write 95. 95 is more than 64 and less than 125. Now 95 is close to be 125. So the cubic root of 125 equals to 5. So the cubic root of 95 is approximately equals 5. The cubic root of 200. 200 is more than 125 and less than 216. The cubic root of 216 equal to 6. So the cubic root of 200 is approximately equals to 6. In this part of the lesson, we need to estimate 1 plus root 5 over 2. At the first, we just solve root 5. We know that 5 is more than 4 and less than 9. And 5 is close to be 4. The square root of 4 equals 2. So instead of root 5, we just write 2. Again, one more time. Just look at the root. Now we have 5. 5 is more than 4 and less than 9. We need to find two squared numbers that 5 lies between them. You will find that we have 5 is more than 4 and less than 9. So we'll find that 5 is close to be 4. The square root of 4 equals 2. And instead of root 5, replace it with 2. So the new number now will be 1 plus 2 over 2. 1 plus 2, which is equal to 3. Divided by 2, the answer now will be equals to 1.5. So 1 plus the square root of 5 over 2 is approximately equals to 1.5. Again in question number 30. At the first, just look at the square root of 60. We have here 60. 60 is more than 49 and less than 64. 60 is close to be 64. The square root of 64 equals 8. So instead of the square root of 60, we just replace it with 8. So we have here 0.25 multiplied by 8. Now 0.25 times 8, the answer now will be equals to. In this problem, we need to arrange from the least to the greatest. We have in question number 34, 7, 9, the square root of 50 and the square root of 85. You will find that we have some of numbers are rational, some of them are irrational. The irrational number, the number that we can't write in the form of a fraction. So we can't compare between rational and irrational numbers. So to solve the problem, just make all of the numbers raised to the power 2. Now 7 to the power 2 equals to 49. 9 to the power 2 equals to 81. And root 50 to the power 2, just we have power 2 will cancel the root. So it will be equals to 50. Root 85 to the power 2 equals to 85. The smallest number that we have now, which is 49. After that we have 50. The next one will be 81. And the last one will be equals to 85. So now we can write the order. The square root of 49 equals to 7. And the square root of 50 will be equal to root 50. Number 3 will be equals to 9. And the last one will be equals to the square root of 85. In question number 35, we have the cubic root of 105, 7, 5, and the square root of 38. By using the calculator, we'll find that the cubic root of 105 is approximately equals to 4.7. The next number now that we have, which is 7. After that, we have 5. By using the calculator, we'll find that the square root of 38 is approximately equals 6.2. Now we need to arrange from the least to the greatest. 4.7 will be the smallest number. After that, we have 5. The next one will be 6.2. And the last one will be equals to 7. So the order now will be equal. The first one is the cubic root of 105. The next one will be equals 5. After that, we have 6.2, which is the square root of 38. And the last one now will be equals to 7. And that's how can we estimate the square and the cubic root.